Hey friends, today we're going to take a look at the vertex form of a quadratic function. Now, just to recap what's been happening at the very beginning of our time together, I had said, hey, we're going to dive into this thing called quadratics, and we're going to look at different forms of how you can write the equation of a quadratic. This is now the third form that we've discussed. The first one being standard form, which was that y equals ax squared plus bx plus c. Okay, the second one we dealt with was factored form, which was a and then bracket x minus r and bracket x minus s. Now we're going to take a look at a new one, and I have it kind of on the screen there, although my head is in the way. I'll hide it for 1 sec. It's this y equals a x minus h all squared plus k. And what we want to do is kind of try and figure out what that a, h, and k are going to tell us. So to do so, those of you who have your workbook with you, you will notice that we have a page here of a bunch of different quadratic equations in this form. We're going to graph each one of them. We're going to try and get a little sketch of them, and we're going to try and figure out what the vertex is and figure out what the y-intercept is, okay? Now, for the first couple, I'm going to do them on a graphing calculator with you, just to remind you of how to use your graphing calculator. Okay, so the first one we have here is y equals x plus 1 all squared minus 2. X plus 1 all squared minus 2. So if you just give me a second, I'm going to switch over to my graphing calculator, and we're just going to remind you how to do all of this. Okay, so Casio kids, you're going to go to menu and then press graph. If you have a newer Casio, it'll be option 5 right here. If you have an older Casio, it'll be option 3. And press 5 and you're looking at your Y1, Y2, Y3, and so on. TI kids, on the top left-hand corner of your graphing calculator, you will see a Y equals button, and that's what you will press, okay? And so in here, we're gonna go bracket x plus 1, and then we're gonna square it, and then we're gonna minus 2, okay? So hit execute to register the equation. And then you can press draw. TI kids, you will press the graph button. It's actually the same in the same spot, this last one on the right, okay? Okay, so now we all have different window settings. If you're a Casio kid, to get to a standard window setting, you're gonna press F3 at the moment to get into your window, and then F3 one more time, and that's gonna give you a standard window, okay? That way we're all looking at the same picture. Then I just exited, and then I drew again, okay? For TI Kid, you have a button up top here that says zoom. You're going to press zoom and then the option 6, and that'll take you to a standard window. So now everybody should be looking at the same picture that I'm looking at. Now, the other conversation I want to have around here is how to play with window settings, okay? What I need you to see here, and just watch my mouse very closely, right here is what we call your X min, and right here is what we call your X max. So when you look at window settings and they go from X min to X max, they're essentially saying, okay, this is how far to the left you want me to go on my window, and this is how far to the right you want me to go on my window. As well, we have a Y min and a Y max, which is how far you want at the bottom is your Y min, and how far you want at the top is your Y max. There is no one way only to do a window. Kids get really, really stressed out because they're always asking me, okay, but what's your window setting? And I tend to try not to tell you what my window settings are because I want you to play around with it. You won't understand graphs as well if you just copy somebody else's window setting. So here's the sorts of things I want you to think about. All this stuff here is wasted space, okay? So I want to bring my X min closer to 0. I want to bring my X max closer to 0. And I want to bring my Y min closer to 0. Okay, so I'm going to change my window settings to be -5 to 5. And then maybe I'm going to go -2 up to 10. And I'm just going to, whoopsie, I'm just going to re-graph that. So I'm going to exit and draw and see if that's a nicer window. Now I actually went a little too far because I want to make sure I see that vertex there. So let's go back and let's go and change that Y min down 1 to -3, just so I don't, just so I have a little bit of space in there. Okay, that's a much nicer picture to me. Okay, now I want to review how you go about finding the max or min, On a Casio, you're going to go G solve. And then remember that all these options up here are your F1, F2, F3 buttons. You just want to go to a min, which is F3. Okay. And so you see that my vertex is at -1, -2. Okay. For TI, you're going to go second trace and then minimum, second trace min. And then what's going to happen is you're going to see your cursor somewhere, and it's probably going to be blinking. And on the right around here is going to say left bound. What that means is you just want to bring your cursor, you're going to right or left button over until your cursor is somewhere left of the hump that you're looking for, and hit enter. It'll then switch the question to right bound. So then you're going to want to bring your, using your right button, bring your cursor over so that it's right of the hump, hit enter, and then it's going to ask you to guess, and then you hit enter one more time, and then that will also give you that -1, oh, sorry. I am talking and pressing buttons at the same time. That will also give you that -1, -2, okay? Okay, so now as far as y-intercepts go, hopefully you'll be able to do this by hand, and you'll plug 0 in for x and solve for y. But while I have the calculator here, let's talk about how to do it on a calculator, just in case you need to check your answer or anything like that. So on a Casio, you'll go back to your G-solve button, press G-solve, and then you'll notice F4 says y-intercept. So you can press F4 and it'll take you right to 0, -1. Okay, 0, -1. On a TI, the easiest thing for you to do is use your trace button. Which actually Casio kids, you can do this too, but if you press trace, okay, and then if you hit 0, the trace button automatically is looking for you to input X. So when you press 0, you'll notice it says, oh, X is 0, and then you hit enter, and we know X is 0 on the Y axis, right? So you hit enter, and then it'll take you to 0, -1 like that, okay? So let's fill in the things that we just figured out. I'm just going to switch back over to my PowerPoint. Okay, and so we have a vertex at -1, -2. We have 0, -1 for the y-intercept, and we have a nice little sketch over there, ready to go. Okay. Again, make sure each time we do this, you're pausing me, you're trying things yourself, and then you're replaying me and checking your work with my work. Okay, so let's go to the next one. Y equals bracket x plus 4 bracket squared plus 6. I'm going to walk you through one more with the graphing calculator. And then after that, I'll leave you on your own with the graphing calculator and just keep showing you the answers, okay? So let's switch over to the graphing calculator. Now, if you are a Casio kid, you can just press exit to go back into your equation setting. And then TI kids, you would go y equals again. Okay, you don't have to delete what's there. You just go ahead and change it. So this was going to be a plus 4 now. And this was going to be a plus 6. So I'm just going to delete what I need to delete, or on a TI, you just write right over it. Okay. Okay, so now I'm going to draw this. My window settings are a little off. Now I can see, okay, I want my X min actually to be farther away. I don't need much of my positive X number line. So I'm probably going to take my positive X only to about 1. I do like to have at least 1 there just because I personally like to see the axis. I like to see the origin in my graph. So let's go to window and let's maybe go from -8 to 1 and see what that might look like. I'd like to go a little higher as well. So let's bring my Y min to be -1. And let's bring my Y max maybe up to 15, just so we see a little bit more of that graph. Let's take a look at what that looks like. That's kind of a nice looking graph. Okay. So again, to get my vertex, I choose to either calculate the max or the min, depending on whether I open up or down. This one opens up, so I'm going to calculate the min, G-solve, which is F5, and then F3 for min, and I get -4, 6. Again, if you're a TI, you're going to go second trace minimum, and then you have to answer the left bound question, make sure your cursor is left of the hump, then the right bound question, make sure your cursor is right of the hump, and then one more enter through the guess, and then you're good to go, and you should also be at -4, 6, okay? And while we're here, just a reminder, the y-intercept, we can go gsolve y-intercept if you're a Casio and get 0.22. If you're a TI, you would want to go trace 0, enter, and you would also get the 22. Okay, so now let's switch back to my PowerPoint, and we'll put all that information here. Okay, and just as a thought, a encouragement, remember we said, hey, you should be able to do the y-intercept by hand as well, right? Anytime you're calculating a y-intercept, you're plugging 0 in for x. So if I plug 0 in here, I would get 0 plus 4, which is 4. 4 squared is 16. 16 plus 6 is 22. So you should be comfortable to get that 22 with or without graphing technology help. Okay. All right. Good. Now we're going to try -2 bracket x plus 1 all squared plus 3. Go ahead and pause me. You try this yourself and then come on back. Okay, so you should have gotten a vertex of -1, 3 and a y-intercept of 0, 1. And this is what your picture should have looked like. Remember, your picture may look slightly off from mine. That just might be because your window settings was 1 or 2 away from what mine was, right? That's okay. There's not one way to think about window settings. But if you're struggling with window settings, look at mine to help after the fact, right? You can see that I went from -4, that would be my x min, and my x max would have been 3, and my y min would have been -5, and my y max would have been 5 for that picture, okay? Okay, and then we're going to try y equals 3, x minus 2 all squared minus 4. Okay, and a vertex you should have gotten there was 2, -4 with a y-intercept of 0, 8. And then that's what your picture should have looked like. Make sure you're practicing this. Okay, x squared minus 5. The vertex you should have gotten was 0, -5, and the y-intercept was also 0, -5. The vertex and the y-intercept were actually the same thing for this one. And then the last one in your table was x minus 3 squared. The vertex you should have gotten here was 3, 0, and the y-intercept was 0, 9. Okay, and then that's the sketch of what you should have seen. All right, so now you're looking at this completed table. I would like to show you the completed table for a second, just with the vertex, and we're gonna just take a quick look, see if we notice anything. Okay, I'm hoping we notice something. The -2 or the k value may be the first thing you notice. Take a look at this, -2, -2, 6, 6, 3, 3, -4, -4, -5, -5, nothing here, right? So that's like a +0, and then, oh, look, 0. Okay, so I think very quickly we could be pretty darn confident to say, hey, that plus k value, whatever that k value is, seems to be the y value of my vertex. Okay, do you see anything about the x value of your vertex? Can you see that in the equation anywhere? Actually, you sort of can. Take a look. +1, -1, +4, -4, +1, -1, -2, +2, nothing, right? There's nothing being added or subtracted from the x there. Nothing. -3, +3. Well, that's cool. So we might want to say that the x value of the vertex looks like it's the opposite number from whatever's being added or subtracted from the x in your equation. Now, personally, I don't really like the whole it's the opposite number. It's actually not the opposite number. I want to explain that a little bit more clearly when I show you the actual equation. So let's go to the next slide here. Quadratic functions can be written in the form ax minus h plus k. So here's the point I want to make. It's minus whatever h is, okay? So if h was 3, it's going to say x minus 3, okay? So h is how you move right or left, if h is 3, you're going to go 3 to the right, but in the equation, it's going to say x minus 3. That doesn't mean h is 3. It means h is positive 3 because it's always x minus whatever h is, okay? Likewise, if h was negative 7, that would mean you're going 7 to the left. But in your equation, that would be written as x minus negative 7. It would look like this, x minus, and then an h value of negative 7. But if we said minus negative 7, that's the same as saying x plus 7. So that's why it looks like it's opposite in the equation. It's actually because it's x minus whatever that h value is, okay? So this is called the vertex form of a quadratic equation, as the vertex is located at h, comma, k. Now, k was the easy one. We just read it exactly as we saw it. So now without your calculator, use the patterns from the table above to complete the table below, okay? So let me open up that table for you and see what you can come up with. We're gonna go row by row, okay? Pause me each time so that you have a chance to think before I show it to you. It's so important that you actually pick up the pencil and try it yourself first. That's how we make the connections. That's how we figure out the math, okay? It's easy for me to click through all the answers, right? It's harder for you to just sit and think about it for a minute, but it's very, very powerful for you to sit and think about it for a minute. Okay, so I'm gonna say I open up because my a value is positive here. This would be a 1 over here. My vertex is at positive 4, positive 6. And my y-intercept, well, 0 for x. So that gives me negative 4 squared, which is 16. 16 plus 6 is 22. So it'd be 0, comma 22. So up 4, comma 6 and 0, comma 22. Next one. Okay, I'm going to go down because my a value is negative. My vertex will be at negative 2, negative 5. And my y-intercept, well, this will be 2 squared, which is 4. So that's negative 4 here because there's a negative in front. Minus 5 is negative 9, so it'd be 0, negative 9. Okay, so I'm opening down, neg 2, neg 5 for my vertex, and 0, neg 9 for my y-intercept. Both the vertex and the y-intercept have to be full coordinate points. Bracket x, comma y, bracket. Be careful with that. Okay, the next one, my a value is positive, so I open up. My vertex would be at negative 1, negative 3. And my y-intercept, if I plug 0 in here, 1 squared is 1, 1 times 2 is 2, 2 minus 3 is negative 1. So I would go up, negative 1, negative 3, and 0, negative 1. Okay, I'm just going to hide myself in case I'm cutting off those first few y-intercepts on you. Okay, all right, the next one, I open down because my a value is negative. My vertex would be at 2, comma 4. And my y-intercept, well, if I plug 0 in here, I'll get negative 2 squared, which is 4. 4 is going to get multiplied by negative 3, which is negative 12. And negative 12 plus 4 gives me negative 8. Okay, second last one. I don't have a h value because there's nothing being added or subtracted to x. So that means my h value is 0 and my k value is 5. So my vertex will be 0, comma 5. I open up because my a value is still positive. And my y-intercept will actually be 0, comma 5 as well because I'm plugging 0 in for x. Okay. And then this last one here, I don't have a k value. My k value would be 0. My h value would be negative 7. So my vertex is at negative 7, comma 0. I open up because my a value is positive. And my y-intercept, if I plug 0 in for x here, I get 7 squared, which is 49. So my y-intercept is 0, comma 49. Okay? How you doing? We got this. Okay, so let's go through a summary together. When a quadratic function is written in vertex form, which is y equals a, x minus h all squared plus k, the function will have a maximum value of k. K is going to be my max or min if the graph opens down, right? I'll have a max if I open down, and that means a is less than 0. Then I'll have a minimum value If the graph opens up, it's still the value of k though, if the graph opens up, and that means that a will be greater than 0, okay? The coordinates of the vertex will be h comma k, and the axis of symmetry is going to be at x equals h. The y-intercept can be found by letting x equals 0 and then solving for y. Okay, so let's just go through a few questions to solidify this together, okay? So I've given you an equation here. For the quadratic function y equals negative x minus 1 all squared plus 4, identify the following without the use of a graphing calculator. I'm just going to hide myself for a quick sec. Okay, the direction in which the parabola opens, well, we know that's going to be down because my a value is negative. The coordinates of the vertex, well, my h value is positive 1, and my k value is 4, so that'll be 1 comma 4. The equation of the axis of symmetry, it's always x equals h. So in this one, it'll be x equals 1. Max or min value, well, I know I have a maximum because I opened down. And I know that value will be at my k, which is 4. So I have a maximum at 4. Domain, remember for all parabolas, all quadratics, it's going to be member of the real. The range, if I have a max, I'm going to be less than whatever that k value is. So y is less than or equal to 4. And now this one's a little new. We're going to write our equation in standard form. Now, that means we're going to take this guy here. Where's my ink? We are going to take this guy here, and we need to get rid of the bracket. So what I want you to see first is x minus 1 all squared means x minus 1 times x minus 1. Okay, so something like that. Now, depending on who your teacher was in grade 10, they may have taught you, okay, we can go x by negative 1. They may have even used the word FOIL here, negative 1 by x, negative 1 by negative 1. Or maybe they taught you to take x and multiply it by the second brackets, and then minus 1 multiplied by the second brackets. It doesn't matter to me as long as you're comfortable going each term. So x by x is x squared. Then I'm going to have x by neg 1, which is neg x. And then we'll have another neg x for this neg 1 times x. And then a positive 1 for the neg 1 times neg 1. Okay. Now I can combine those middle terms. So that'll be negative 2x in the middle. The next thing I have to do is distribute this negative. So this is going to be negative x squared, positive 2x, and minus 1. Okay. Then I can just add that negative 1 and 4 together. Those are both like terms. So I can end with negative x squared plus 2x plus 3. Now, what I want to make note of is this equation and this equation are the exact same equation, okay? It's just that the top one is written in vertex form and the bottom one is written in standard form, okay? But they're the exact same parabola. All right, good work, my friends. Okay, determine the value of a if the point 1, 1 is on the quadratic function f of x equals a times x plus 2 all squared minus 3. I'm just going to hide myself here for 1 sec. Okay, the cool thing about being given a point is I can always use that point as a value for x and y. So right now I've got a y value, I've got an a value, and I've got an x value. If I use that 1, 1 as my point for x and for y, I'd have numbers in there for everything but a, and then I would be able to solve for a. Okay, so that's exactly what I'm going to do here. I plugged in 1 for x and y. Now I'm going to solve for a. I'm going to add 3 to both sides, so there'll be a 4 over here. 1 plus 2 is 3, and 3 squared is 9, so this will be 9a. Okay. Then I would have to divide both sides by 9, and I would get a equals 4 over 9. Okay. Awesome. A parabola with a vertex of negative 1, 5 passes through the point negative 2, 3. Determine the equation of the parabola in vertex form. Well, actually, this is pretty similar to the question I just asked you. The difference was I had already established in the equation what h and k were. Here, I actually told you h and k, but I didn't put it in an equation. I just told it to you from telling you the vertex. So I know that this is my h and this is my k. And then this is going to be my x and y in the moment to solve for my a value. I need to figure out the a value to write the equation. Okay, let me hide myself just so you can make sure you read the whole question. Okay, and then that's what we're going to tackle here. So we're going to go y equals a, x minus hl squared plus k. That's just the standard formula. And I'm going to plug in my h, my k, my x, and my y. Okay, so h was -1. So because it says minus -1, I changed that to +1. K was 5. X was -2. And y was 3. Okay, now to get a by itself, I got to do this algebra. I'm going to subtract 5 from both sides. So I'll have a -2 on this side. -2 plus 1 is -1. -1 squared is is 1. So that leaves me with 1 times a, which is just a. So I get down to -2 equals a. And now that's not the answer to this question because the question actually said, what is the equation? So the equation would be this guy here with my h, my k, and my a stated. Okay, so it would look like this: -2, y equals -2, x plus 1 all squared plus 5. Okay. State the domain and range. Well, we know the domain is always going to be x as a member of the reals for quadratics. And then for the range, I know I open down because my a value is negative. I know my maximum then would be 5 because that's my k value. And so I can say that y is less than or equal to 5. Okay. Awesome. And then the last question here is to write it in standard form. So we did one of these already. We'll do one more. We need to remember that this x plus 1 all squared means x plus 1 times x plus 1. And then we got to go first outside, inside last. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. So that's going to leave me with x squared plus x plus 1. I would now need to distribute the -2. So that's going to be -2x squared. This is going to be a 2x. So that's going to change into a -4x in a minute. And then this is going to be a -2. Okay. So I did that in 2 steps. I just collected my middle terms first, and then I distributed my -2. And then the last thing to do is to combine this -2 and 5 together to get 3. So in standard form, it would be y equals -2x squared minus 4x and plus 3. Okay. Awesome, guys. You are doing fantastic. Hopefully this is not as scary as it might look at the very beginning. Okay, so that's it for today. I've posted your homework if you're my kid at school. And in the meantime, make sure you're doing your work and make sure you're asking me questions. Next up, we're going to deal with kind of very similar to this last question that we did. We're going to dive more into determining equations. Okay, so I'll see you there. Keep mathing.